Okay, let's unpack this. When we look at a finished building, we often see the triumph of design, right? The soaring lines, the perfected aesthetic.
Yeah, the final polished product.
Exactly. But what about the incredible, often gritty journey it took to get there? I mean, think about trying to capture something as immense and dynamic as a building rising from the ground.
It's a huge undertaking, constantly changing.
It really is. It's not just the final gleaming structure that tells a story, but every single step, from the very first conceptual sketch to the last meticulous detail of construction. So how do we even begin to document such a monumental, ever-changing process? And, well, what makes these records so vitally important?
That's a profound question, really. What's truly fascinating here is how the act of documentation, of visually and textually representing, is deeply intertwined with the very act of building itself.
It's not just an afterthought.
Not at all. It shapes not just the historical records of our built world, but our understanding of architecture and even its future trajectory. This isn't simply about, taking pretty pictures or drawing lines on paper.
Right.
It's about capturing knowledge, verifying work, communicating complex intentions across vast, multidisciplinary teams, and spanning enormous timelines sometimes.
Distance.
So it prompts us to ask, what tools have we historically employed, and what cutting-edge technologies are we utilizing now to truly see and understand the entire construction process, from that first spark of an idea to the final flourish?
That's precisely the mission of our deep dive today. We're going to explore how humanity has continually strived to remember and share the intricate, often heroic process of creating our built environment.
Yeah, digging into that evolution.
We'll trace how documentation has evolved, from the insightful treatises of ancient builders to the sophisticated digital models of today, and unpack the crucial role various forms of visual records play in every stage of construction.
And where are we drawing this from?
Well, to guide us, we've pulled together fascinating insights from seminal architectural history texts, practical project management guides, and modern building information modeling handbooks. Our aim is to uncover the diverse ways we capture the essence of building, the fundamental reasons behind this meticulous documentation, and what these enduring records ultimately tell us about the structures themselves and the ingenious people who bring them to life. So, before the advent of cameras, before photography could freeze a moment in time, architects and builders were, in essence, their own meticulous visual documentarians, right? Using pen, paper, maybe even chisel to capture every detail.
That's right. They had to be.
It's truly remarkable how much complex information they managed to convey and preserve. But I wonder, how did they handle the actual, often messy and incredibly physical process of building itself long before, modern project management?
Indeed. And if we look closer, these early forms of documentation weren't just static blueprints or pretty sketches. They were critical knowledge transfer mechanisms.
So passing down the know-how.
It's exactly. Shaping building traditions and ensuring continuity across generations. They embodied a living craft. This then prompts us to consider a pivotal shift. What happens when the scale, complexity, and sheer speed of construction begin to demand a far more dynamic, more real-time method of capturing progress and ensuring adherence to vision?
It's incredible to consider that the fundamental human urge to record design isn't a modern phenomenon. It goes way back.
Oh, absolutely. Centuries, millennia even.
Long before anything resembling photography existed, architects and builders meticulously documented their visions, often in, excruciating detail. Take ancient texts, for instance. We're talking about foundational works like Vitruvius's 10 books on architecture, penned way back in the 1st century BC.
Like cornerstone text.
Or Andrea Palladio's The 4 Books of Architecture from the 16th century. These weren't merely theoretical treatises, were they?
Not at all. They were highly practical guides, filled with detailed descriptions and intricate drawings. They served to document everything from, immutable design principles to specific construction methods, and even the anticipated finished appearance of buildings.
Right down to the proportions and ornamentation.
Precisely, down to the finest details.
From Vitruvius, for example. The level of detail is just staggering.
Yeah.
He didn't just mention temple doorways. He specified their distinct styles, Doric, Ionic, Attic, and provided these precise geometric instructions for their proportions.
Almost like scientific specifications. He laid out exactly how column spacing, like U-style, which means columns spaced at precise intervals of 2 1/4 column thicknesses.
Okay, very specific.
Or even wider middle intercolumniations of 3 thicknesses. He understood how this dramatically affected not just the visual rhythm, but also the structural stability and the whole aesthetic harmony of a temple. He even provided formulas, almost like ancient algorithms, to determine door aperture height and width based on the temple's overall height. This wasn't guesswork. It was a deeply ingrained system of meticulously documented symmetrical proportions.
Passed down and refined over time.
Exactly. Designed to achieve specific, predictable architectural effects that spoke of order and beauty. It's really the birth of architectural theory as a documented, transmissible discipline.
In Palladio, centuries later during the Renaissance, he powerfully continued this legacy, didn't he? In many ways becoming the standard bearer for documented architectural principles.
He certainly did. His influence is undeniable.
His 4 books weren't just a collection of his own innovative designs, which, went on to inspire countless architects globally.
Still do, really.
Right. They also included detailed analyses and reconstructions of ancient Roman works, which he apparently meticulously measured and redrew.
That's a key part of his contribution. Looking back to understand the present, he presented, for instance, his famous arcades of the Basilica in Vicenza.
Ah, the Palladian motif.
That's the one. That distinctive combination of a central arch flanked by narrower rectangular openings, often capped by a smaller arch. Very influential.
And he didn't just show the finished product, right? He detailed specific country houses, like the one for Signor Francesco Baduro in the Polesine.
Yes, with deep insights into everything from pavement height and the complex geometries of vaulted halls to the precise proportions of individual rooms. He was focused on ensuring their harmonious relationship within the larger structure.
He even got into the engineering side.
Oh, yes. He delved into the engineering feats of antiquity, describing Julius Caesar's Rhine Bridge with specific iron cramps and beam dimensions. It just demonstrates an astonishing level of detail in both written and drawn documentation.
So it was essentially a comprehensive visual and textual record, capturing not just the idea of architecture, but its tangible, buildable reality and its intellectual lineage, too.
Precisely. Moving beyond just documenting the design ideal, we also find evidence that ancient documentation implicitly captured the practicalities of construction itself.
How so? Like beyond the drawings?
Well, Spiro Kostov's A History of Architecture Settings and Rituals gives us fascinating glimpses into this. He describes ancient structures like the monumental ziggurat of Ur-Nammu at Ur, dating back to around 2000 BC.
Wow, ancient.
Very, with its massive core of mud brick and a thick facing of baked brick set in durable bitumen mortar. But what's truly remarkable are the calculated diversions. Kostov identifies the sloping, slightly convex walls and curved ground plan.
Calculated diversions, you mean they weren't straight?
Exactly. They were intentionally built into these colossal structures. These weren't accidental. They were carefully engineered to correct the visual stiffness and that sense of inert mass that strict rectilinearity might otherwise induce in buildings of such immense size.
So an optical illusion, basically, built in.
In a way, yes. It wasn't merely building by rote. It was an advanced understanding of perception and engineering, clearly part of an evolved and meticulously practiced, even if informally documented, construction tradition.
It makes you wonder how that sophisticated knowledge of structural integrity and optical illusion was precisely passed down and implemented across such vast projects.
It's a fascinating question.
We see further compelling evidence of this advanced structural understanding in medieval vaulting diagrams. These often complex diagrams, sketched by master masons, they show that builders had an incredibly detailed, almost intuitive grasp of statics and load distribution.
They really understood how forces worked in stone.
Totally. They knew, for example, that pointed arches, struck from 2 centers, would remain structurally sound and allow for taller, wider, more open spans, efficiently directing thrust downwards.
Compared to round arches.
Right. In stark contrast, they understood that round-headed arches would flatten and weaken significantly under similar loads, necessitating thicker walls or more robust buttressing. This isn't just about the aesthetics of Gothic architecture, is it?
No, it's fundamental engineering. It's about a deep, documented understanding of structural considerations that ensured the stability, the gravity-defying grace, and the sheer longevity of those magnificent cathedrals, many of which still stand today.
Absolutely. The medieval era really exemplifies the power of not just theoretical, but practical craft-based documentation. Jean Gimpel's The Cathedral Builders highlights the absolutely crucial role of craftsmen's knowledge and their invaluable sketchbooks.
Like Villard de Honcourt's.
Exactly. His 13th century sketchbook, for instance, was an indispensable visual document, a sort of portable encyclopedic textbook for builders and artisans across Europe.
Full of details, right?
Oh, yeah. Intricate details of architectural elements, construction techniques, geometrical layouts, structural solutions, everything from a rose window design to a lifting mechanism. These sketchbooks functioned as a living repository of shared collective knowledge.
Maintaining and transmitting building traditions across generations in a coherent, highly skilled culture. It's a different model of knowledge transfer than we often see today.
Definitely. Gimbel contrasts it with the often fragmented, specialized way architectural knowledge was transferred in, say, 20th century U.S. architecture. It suggests a profound shift away from the hands-on, directly observed and visually documented learning embedded in such invaluable personal records.
Interesting contrast.
And it wasn't just about the building's form or structural systems. Documentation also extended to the very materials used, tracing their journey from raw earth to finished component.
Right, the whole supply chain, essentially.
Consider Georg Agricola's monumental De Re Metallica, published back in 1556. While its primary focus was mining and metallurgy, it provided incredibly detailed accounts of the processes for extracting and preparing materials vital for construction.
Like metals.
Exactly. For example, it vividly described how to smelt lead ores, how to separate precious gold and silver from base metals, and the specific use of various fluxes substances like lead, copper, soda, saltpeter, vitriol, alum, iron filings.
Things needed to work the metals.
Right. Things that were absolutely essential in refining and working metals. This demonstrates an early, meticulous form of industrial process documentation, capturing the origins, preparation, and transformation of the very components that quite literally brought structures to life, brick by brick, beam by beam.
And we also see the architect's individual vision becoming a powerful form of documentation, even when expressed through deeply personal narratives rather than, strict blueprints.
Like Frank Lloyd Wright.
Exactly. Frank Lloyd Wright's autobiography, for instance, doesn't offer technical construction details in the same way. Instead, it vividly reflects his architectural vision and innovative approach through his profound introspections and relationships.
So understanding the person helps understand the building.
Precisely. Understanding his documented ideas, his personal philosophy, and his professional journey helps us grasp the underlying essence and radical departures of his creations, seeing the why behind the what.
That's a crucial point. Wright famously defined good architecture as an embodiment of truth, beauty, and a response to the environment and human needs.
Powerful statement.
And in essence, any form of documentation, whether it's Vitruvius's proportions, a medieval vaulting diagram, or Wright's deeply personal reflections, ultimately aims to capture this underlying philosophy, what a building means, how it relates to its surroundings and its inhabitants, and the fundamental needs it serves.
It's a holistic view, yeah. Transcending mere technical details, aiming for something more profound.
But if documentation aims to capture that philosophy, do you ever find that the technical details, the how-to of building, can sometimes overshadow the why, the larger vision of truth and beauty?
It's a constant tension, isn't it? The challenge is always to ensure that the rigorous technical documentation serves the larger vision, rather than becoming an end in itself.
Right, keep the focus.
And that brings us directly to a pivotal shift. How did we bridge this gap from documenting the ideal to systematically capturing the messy, dynamic reality of the process itself?
The construction phase.
Yes. This transition, from representing a finished vision to meticulously recording the ongoing construction, fundamentally transforms documentation into a tool for control, verification, and crucial accountability.
Which raises the question.
Exactly. How have digital technologies, from simple images to complex models, pushed this evolution even further, enabling entirely new ways to see and manage the intricate dance of modern construction?
The journey from ancient pen and paper treatises to systematic visual records really picks up speed with the demands of modern project management. The Project Management Institute's PMBOK guide.
The PMBO, yes, standard stuff for project managers.
Right. The project management body of knowledge, a foundational text in the field, it emphasizes that construction projects, just by their very nature, require significant upfront planning.
Makes sense. A lot of moving parts.
Totally. Planning to account for design, approvals, materials purchasing, logistics, and delivery. This intensive, multifaceted planning necessitates equally robust, systematic documentation practices to keep everything on track.
You can't manage what you don't measure or document.
Precisely. What's more, the guide points out that project teams themselves often possess the best insight into the most suitable tools for documentation.
Though that's often balanced against cost, right?
Exactly. Though these choices are naturally tempered by critical factors like cost efficiency and existing organizational constraints, you use what works and what you can afford.
This leads us directly to the absolutely critical role of systematic progress photography in modern construction management.
Okay, so actual photos of the work being done.
Yes, the Construction Management Standards of Practice from the CMAA, the Construction Management Association of America, explicitly requires progress photos and photos of existing conditions prior to the notice to proceed.
So before you even start, you document what's there.
Absolutely essential. And this isn't just a suggestion. It's a fundamental contractual and quality assurance requirement on job sites. These photos aren't isolated snapshots. They're an integral part of thorough documentation of daily inspection efforts.
Part of a bigger package.
Exactly. Existing alongside detailed inspection reports, various project data, and all project correspondence, forming a comprehensive historical archive.
It makes perfect sense, especially when you think about the sheer scale and complexity of today's builds. The purpose of these photos goes far beyond just showing what's happening. It's about establishing a verifiable record.
Proof. Visual proof.
Right. They're used to diligently verify compliance with contract specifications, meticulously monitor work quality, ensuring everything meets the agreed-upon standards, and to build an unimpeachable historical record of the entire construction phase.
And this has legal weight, too, presumably.
Oh, absolutely. This means connecting them to broader legal and archival needs. Progress photos directly supplement record drawings, plans, prepared after construction is complete, that represent the work accomplished under the contract.
So they back up the final drawings.
They offer indisputable visual proof of conditions at various stages, which is absolutely crucial for liability protection, resolving potential disputes, and serving as vital evidence in legal contexts, as highlighted in construction law, through various court cases involving contractual agreements. They underscore why such meticulous documentation is so critically important in a world where every detail can have significant implications.
However, documenting on a dynamic construction site is far from a simple point-and-shoot task. These environments are inherently chaotic, constantly changing, and often hazardous.
Yeah, safety must be a huge concern.
Huge, posing significant challenges for comprehensive documentation. Safety considerations, for instance, are absolutely paramount, as the CMAA standards strongly emphasize robust safety programs and the owner's unwavering commitment to them.
The CM's role is key there.
Crucial. The construction manager, CM, has a critical proactive role in reviewing contractor documents for adequate safety language, and it's made abundantly clear that any CM staff observing a safety hazard must immediately bring it to the contractor for prompt corrective action.
So documenting safely is part of the job.
It has to be. While not directly about photographing safety challenges, this context underscores the complex, high-stakes, and often dangerous nature of the environments where this vital documentation must occur, requiring careful planning and execution.
Beyond safety, there's the sheer complexity and logistics of managing large-scale, multi-phased projects. They demand incredibly careful scheduling and coordination.
Keeping everything moving in the right sequence.
Exactly. The CMAA mentions essential tools like the short-term construction activity plan or a rolling schedule or even a look-ahead schedule. These plans map out activities week by week, often using key milestones.
And visual documentation helps track that.
Indispensable. Including progress photos, it becomes an indispensable aid in monitoring and verifying that these complex sequences are being followed as planned. I mean, imagine trying to coordinate hundreds of tasks, thousands of workers, millions of parts without a clear visual record of what's been accomplished and what's next.
That would be chaos, pure chaos.
It would be a nightmare.
And when it comes to reporting progress to diverse stakeholders, visual representations become even more potent and universally understandable, don't they?
Absolutely. The CM is specifically tasked with preparing and distributing appropriate reports to the owner and other appropriate parties, describing and depicting graphically actual progress on the project.
Graphically, that's the key word.
During the design phase relative to the project plan. This powerfully reinforces the essential role of visual aids in communicating progress effectively, whether that's through detailed charts, insightful diagrams, or, of course, a well-curated series of progress photos. These visual narratives offer clarity that dense text alone often struggles to provide.
It connects beautifully to the timeless principles from Edward Tuft's seminal work, the visual display of quantitative information.
Ah, tough day, the guru of data visualization.
All right. Tough Day emphasizes the profound importance of well-designed data graphics to make complex information clear, concise, and immediately interpretable.
Even though he's talking charts, not photos.
Exactly. While he's talking about charts and data rather than just construction photos, the underlying principle is exactly the same. Visual representations, when effectively designed and thoughtfully presented, can convey a tremendous amount of complex information far more efficiently and memorably than prose alone.
So a picture is worth 1,000 words if curated properly.
Precisely. For instance, a series of progress photos, carefully selected, sequenced, and contextualized, can instantly communicate the intricate journey of a building's construction, providing a clarity and narrative arc that dense text might struggle to achieve. The insight is that when we treat these images as data, curating, sequencing, presenting them thoughtfully, we unlock a far richer understanding than text alone could provide.
Turning documentation into actionable intelligence.
Yes. Tufts examples, like those Consumer Reports frequency of repair records for cars, brilliantly illustrate how complex comparisons between manufacturers, types, common trouble spots can be made remarkably clear through thoughtful visual design.
Makes sense.
This principle applies directly to how even seemingly simple progress photos convey complex information efficiently. They are, in a sense, a form of visual data that, when well executed and organized, offers profound insight into both the quantitative and qualitative aspects of a project's evolution.
So that progression from basic site photos to more structured, visually driven reports is a big leap.
A significant leap in how we leverage images for project intelligence and decision-making. Absolutely.
The shift from simple static progress photos to these incredibly sophisticated digital models and simulations is astonishing. It's like going from a single snapshot to a living, breathing, predictive blueprint of the entire project.
It really is a paradigm shift.
It truly is. So with this leap in technological capability, what does this all mean for the diverse range of people actually using and relying on these powerful tools?
Well, what's genuinely fascinating here is how building information modeling, or BIM, not only meticulously documents, but also profoundly predicts and actively optimizes the entire construction process.
Predicts and optimizes. How so?
It truly transforms documentation from a retrospective record into a proactive management and design tool. It's about solving problems before they arise by fostering a deep, integrated understanding of the project's logic and methodology.
Okay, proactive problem solving.
Which then leads us to a crucial question. How did these advanced forms of documentation, with their incredible detail and dynamic capabilities, specifically serve the multitude of diverse stakeholders involved in a modern construction project?
The digital transformation of visualizing construction is truly a game changer, with building information modeling, or BIM, leading the charge as an epical transition, as the BIM handbook describes it.
Apical transition, strong words.
They are, and it's far more than just an upgrade to traditional computer-aided design, or CAD. CAD primarily automates the production of two-dimensional drawings, basically digitizing the drafting board. BIM, by contrast, is a fundamental paradigm change because it redistributes the allocation of effort, placing more emphasis on conceptual design.
So more thinking up front.
Exactly. It pushes critical decisions and problem-solving to much earlier stages in the project lifecycle, fundamentally altering how design and construction interact.
That's a critical distinction, and it underpins BIM's revolutionary impact. BIM isn't just about making prettier drawings faster or more efficiently. It's about creating a parametric model.
Parametric model. What does that mean exactly?
Essentially, it's a smart 3D model where objects and elements are defined by rules, relationships, and embedded data, rather than just static lines and shapes.
So the parts know about each other.
In a way, yes. Change one dimension of a wall in a parametric model, and all related elements, connected walls, windows, doors, even structural components automatically update, maintaining consistency.
Wow, that's powerful.
It is. This ensures incredibly accurate takeoff accuracy for cost estimates, meaning precise material quantities can be extracted directly and dynamically from the model. This allows for rapid feedback on cost, which is then represented graphically in the 3D model, providing immediate visual financial implications for any design changes.
Minimizing errors in estimating.
Exactly. It minimizes the errors and omissions that often plague traditional manual estimating methods, making cost control far more precise.
And it creates a far more comprehensive and interconnected representation of the entire project, right?
Absolutely. The BIM handbook details how BIM supports not just fundamental geometry and material layout, but also sophisticated structural and energy analyses, allowing for performance simulations.
So you can test the building virtually?
You can. It can even integrate non-geometrical information like construction schedules, transforming a static model into a 4D simulation, showing how the building will be assembled over time.
4D, adding time to the 3D model.
Correct. Furthermore, it supports the creation of highly detailed fabrication models for specific subsystems like structural steel, precast concrete, complex piping networks, intricate electrical layouts.
Down to the nuts and bolts.
Pretty much. And what's truly key here, and a cornerstone of BIM's power, is interoperability.
Meaning different software talks to each other.
Yes, the ability to seamlessly pass data between different software applications and disciplines. This eliminates the tedious and incredibly error-prone need for manual copying of information, which, as the handbook notes, greatly discourages crucial iteration during design and inevitably leads to inconsistencies and costly errors further down the line.
So less copying, fewer mistakes, more design exploration.
That's the idea. This profound interoperability fuels advanced visualization and simulation capabilities that were previously unimaginable. For instance, in the critical conceptual design phase, tools with deprofiler functionality allow for the rapid definition of initial building concepts from a cost and operating cost basis.
So early cost feedback.
Very early. Architects can quickly lay out building types based on room types, structural system site parameters, often using an easy 3D sketch manner with intuitive editing operations, almost like sketching directly in 3 dimensions.
Like digital clay.
Sort of. A building can be composed as a set of spaces, floor by floor, or alternatively as a shell that is then decomposed into floors and assigned specific spaces. Even complex site plans can be rapidly defined using imported terrain models or segments from services like Google Earth.
So you can see the whole thing early on.
And understand its implications. This allows for incredibly early, detailed visual exploration of design concepts and their immediate financial and operational implications before any significant investment is made.
But the real power of BIM truly comes into its own when taking these sophisticated models onto the virtual job site long before any physical ground is broken.
The pre-construction phase, yeah.
The CMA standards of practice highlight the construction manager's use of BIM for incredibly robust design review. This facilitates multiple group review meetings involving all stakeholders and, crucially, enables virtual hard-at reviews.
Virtual hard-at reviews. Sounds cool.
It is. Imagine being able to conduct a virtual walkthrough of the model, exploring every nook and cranny, to meticulously examine job site logistics or review the facilities being constructed or renovated. It's like having a time machine for construction.
Allowing you to identify potential issues and optimize processes in a risk-free digital environment.
Exactly. And a crucial, immensely valuable aspect of these virtual reviews is clash detection exercises.
Finding where things collide. Pipes hitting beams.
Precisely. These are meticulously performed to identify physical conflicts, spatial constraints, and to facilitate better coordination among various disciplines. For example, the BIM handbook provides a striking illustration showing how physical spaces can be modeled to represent weld crew workspaces.
So even worker safety.
Yes, allowing designers to find potential unsafe interferences between workers or between equipment and structural elements long before they manifest on the actual site. Or imagine visualizing the overall frame of something as complex as the Yas Island Formula One structure, identifying where a massive HVAC duct might clash with a structural beam or a plumbing line.
And resolving these conflicts in a 3D environment.
Exactly. This proactive approach saves immense amounts of time, prevents costly rework, and significantly enhances both safety and constructability.
The visualization capabilities of BIM don't stop at problem solving, though. They extend powerfully into communication and public relations, transforming how projects are shared.
How does that work, showing models to the public?
Essentially, yes. The CMAA notes that the construction manager can assist the owner in public relations activities, particularly to communicate the project with the community and with parties that will be impacted by the project, by skillfully using the BIM model and creating phasing and 4D simulation.
Ah, the 4D again, showing the timeline.
Right. This moves far beyond simple static photography to dynamic visual storytelling of the entire build process. Imagine showing local residents a time-lapse animation generated from the BIM model, illustrating how a new bridge will be constructed over months, how traffic flows will be temporarily diverted, and what the finished structure will look like in its context.
That sounds incredibly useful for getting community buy-in.
It's a powerful way to engage, inform, and build support for complex, often disruptive projects.
Looking ahead, BIM is also proving to be an incredibly potent tool for continuous improvement and invaluable corporate knowledge management.
Capturing lessons learned.
Exactly. The BIM handbook describes how software wizards, using parametric templates of work packages with embedded construction methods, will be applied to rapidly compile a construction model from a design model. These templates are far more than just convenient shortcuts.
They're knowledge repositories.
Yes, they serve as a dynamic repository for corporate knowledge, effectively embedding a company's specific way of working, its accumulated best practices, and hard-won lessons learned directly into the software itself.
Can you give an example?
Sure. A parametric template for a specific type of post-tensioned flat slab could automatically lay out optimal formwork design, determine precise labor and equipment inputs, calculate exact material quantities, and even generate detailed delivery schedules based on a generic slab object within the design.
Wow, so it automates a lot of the standard practice.
And captures it. This creates a powerful feedback loop for organizational learning.
That's fascinating, because it means that every new project can literally build upon the accumulated wisdom and efficiency gains of previous ones, leading to continuous refinement and optimization across the organization.
This profound capability also extends powerfully to cost control and strategic value engineering.
Making sure you get the best bang for your buck.
Right. The CMAA highlights how model-based budgeting and estimating can be maximized, allowing for sophisticated options analysis and value engineering, including exercises to modify the design to match the budget.
So you can tweak the design and see the cost impact immediately.
In real time, yes. BIM allows for quick, iterative changes to a design, immediately showing the precise cost impact. This empowers project teams to optimize value and performance without sacrificing quality, aesthetic vision, or critical functionality.
Making cost management a truly dynamic, integrated process, not just an accounting exercise afterwards.
Exactly. It's clear now that documenting construction goes far beyond just pretty pictures or technical drawings. It's a multifaceted necessity, almost a universal language that helps everyone involved speak the same truth about the project.
A common ground.
But with all these sophisticated tools at our disposal, what are the inherent difficulties in achieving truly comprehensive and accurate documentation? And how do we ensure that this rich tapestry of information truly reflects the complex reality on the ground?
That's the million-dollar question, isn't it? If we connect this to the bigger picture, the diverse purposes of documentation, from rigorous legal compliance to effective public relations and internal knowledge transfer, underscore the sheer complexity of modern construction projects and the multitude of viewpoints and needs involved.
So many stakeholders, so many demands on the documentation.
Precisely. This then leads us to a crucial question.
Yeah.
What are the underlying challenges in truly capturing, managing, and effectively leveraging all of this intricate information, and how can we use these insights to build not just smarter, but more adaptively and resiliently?
You've hit on a truly crucial point. Construction documentation, in all its forms, serves a multitude of purposes, extending far beyond simply creating a historical record. One of its most primary and foundational roles is rigorous project oversight and quality assurance.
Making sure the job gets done right.
Exactly. This documentation, including those vital progress photos and detailed inspection reports, is absolutely essential for verifying that work is being performed in accordance with the quality requirements of the contract documents as meticulously stipulated by the CMAA. It's not passive observation either. No, it includes actively ensuring that daily testing and inspection procedures are rigorously accomplished when appropriate, providing irrefutable proof of adherence to standards.
And this leads directly to the critical need for comprehensive record-keeping for auditing and accountability.
The paper trail, or the digital trail now, I guess.
Right. The CMAA explicitly emphasizes maintaining thorough documentation of daily inspection efforts, which means not just progress photos, but all pertinent project data and correspondence. This includes everything from contractor submissions and owner approvals to detailed shop drawings, various logs, and certifications.
The whole kit and caboodle.
Essentially creating a complete, transparent, auditable history that confirms compliance, assigns accountability, and allows for meticulous tracking across all project phases.
And managing changes.
Crucial. Such robust documentation provides the indispensable basis to review and assess any authorized extra work under the contract as to its effect on construction time, cost, and quality, ensuring that changes are properly managed, justified, and precisely accounted for, minimizing disputes and unexpected costs.
Beyond internal project management and quality control, documentation also fulfills absolutely critical legal and contractual requirements, acting as a shield and a sword in potential disputes.
Evidence. Hard evidence.
Absolutely critical evidence in legal contexts, particularly in contract disputes, as numerous court cases referenced in construction law vividly illustrate. Agreements, even those with points of detail yet to be fully agreed upon or seemingly minor omissions, can be contractually binding.
So the documents matter hugely.
They can quite literally make or break a legal argument, proving when and how certain actions were taken or not taken.
Regulatory compliance is another huge non-negotiable driver too, isn't it?
Oh, massive. Buildings must adhere to a complex, constantly evolving web of federal and national codes, like the Americans with Disabilities Act, ADA, and the Federal Fair Housing Act.
Plus local codes.
Right, alongside locally adopted model codes like the International Building Code, IBC. Documentation serves as the primary means to verify strict adherence to requirements for fire resistance ratings, allowable building heights, and areas based on construction type, occupancy, sprinklers.
Means of egress, accessibility.
All of it. For instance, Building Codes Illustrated details specific criteria for accessible fixtures, water closet dimensions, clear floor space, grab bars, etc. All these details must be meticulously documented, verified, and readily available for inspection and approval.
Demonstrating due diligence and ensuring public safety and accessibility. It's essential.
All this incredibly detailed information also plays a massive central role in facilitating effective communication and robust collaboration across the often disparate, diverse project teams.
Getting everyone on the same page.
Exactly. BIM models, as we discussed, significantly enhance visualization and communication, not just for the immediate project team, but for owners, user groups, and other stakeholders.
Letting them see the project.
The CMAA highlights how these models allow them to see their project virtually and minimize the potential for changes after the building is constructed, fostering greater understanding, building essential consensus, and securing crucial buy-in from all parties involved long before physical construction begins.
And that improved visualization directly facilitates a far more efficient design review and coordination process, right?
Absolutely. By enabling multiple group review meetings and detailed clash detection exercises, as outlined in both the CMAA standards and the BIM handbook, comprehensive documentation ensures significantly better coordination among various design disciplines, structural, mechanical, electrical, plumbing,
preventing costly conflicts and rework before construction even begins. It even extends to critical public relations efforts.
We touched on that, using models to communicate with the community.
Yes, where BIM models and dynamic 4D simulations are expertly employed to communicate the project with the community and with parties that will be impacted by the project, transforming complex construction plans into accessible, engaging, and reassuring narratives.
Finally, documentation is absolutely vital for knowledge transfer, continuous organizational learning, and creating a lasting historical archive for future generations.
Passing the torch.
Within BIM, for instance, those parametric templates we talked about serve as a repository for corporate knowledge, embedding a company's specific way of working, its accumulated wisdom, its unique best practices directly into its operational processes.
So the company itself learns and improves.
This is precisely how companies learn from past projects and continuously improve their methodologies, ensuring that valuable insights are not lost but systematically integrated.
And this learning extends beyond formal corporate systems too, doesn't it? Spilling into the very fabric of our built environment.
How do you mean?
Well, Stuart Brand, in his insightful book, How Buildings Learn, discusses the fascinating idea that buildings, in a sense, learn from each other.
Buildings learn?
Passing on informal and casual and astute wisdom through generations of experience and observation. This concept applies powerfully to vernacular architecture, common, ordinary buildings not designed by professional architects, which he notes is profoundly cautious and imitative.
Learning through tradition and imitation.
It reflects an ongoing informal documentation process, a collective memory embedded in practice running right alongside the more formal, systematic ones we've discussed. It's the wisdom of tradition made tangible.
Brand makes a really practical, almost poetic recommendation for long-term historical archiving, too, one that resonates deeply with our theme.
Oh, yeah. What's that?
He suggests diligently photographing foundations and drainage systems before they're filled in, and meticulously documenting septic systems and trenches.
Why? Because they get buried.
His reasoning is wonderfully pragmatic. Everything that is buried will be dug up one day. It's better to leave a treasure map.
A treasure map. I like that.
It perfectly encapsulates the immense long-term historical value of even seemingly mundane construction photography and documentation. These records ensure that future generations, whether they are carrying out maintenance, planning modifications, or simply trying to understand the original intent of a structure, have the crucial insights needed literally at their fingertips.
That's a great takeaway.
Yeah.
Document the hidden stuff.
The process of documenting a building is clearly as complex, dynamic, and multi-layered as the building itself. From ancient texts codifying beauty to predictive digital models guiding every bolt, it's all about capturing a fleeting reality and solidifying a vision.
A huge undertaking.
But as we stand at the precipice of even more advanced technologies, what are the inherent difficulties that persist? And how do we ensure that this rich tapestry of documentation truly reflects the dynamic, often messy, reality of construction?
Yeah, that's the crux of it. What's truly fascinating here is that while technology allows us to capture more and more granular detail, the fundamental challenge remains constant: to make comprehensive sense of that enormous volume of information.
Avoid drowning in data.
Exactly, to prevent it from overwhelming us, and crucially, to use it to genuinely learn and improve future projects. This then leads us to a profound question. When we create such exhaustive digital records of our built world, are we truly archiving its reality, or are we, in a way, constructing an entirely new, digitally augmented reality that might someday become the dominant narrative of the structure?
That's a heavy thought. But let's dig into those challenges first. As fascinating as all these advancements are, documenting the built world is still riddled with inherent difficulties, particularly concerning complexity and control.
It's never simple.
Highly complex projects, just by their very nature, present enormous difficulties in sheer coordination and oversight. In BIM design projects, for instance, managing multiple database structures, the various software platforms, proprietary formats, data schemas used by different consultants and contractors can be a significant hurdle, as the CMAA notes.
Getting all the systems to talk to each other seamlessly.
It's a constant battle. Ensuring seamless communication and data exchange across these disparate systems is tough.
And it goes deeper than just technical data management, doesn't it? There are systemic issues.
Like what?
Well, Danella Meadows, in Thinking in Systems, highlights that delays and feedback loops are critical determinants of system behavior and are common causes of oscillations.
Delays causing instability.
Exactly. This applies directly and powerfully to construction, where, for instance, it takes several years to design and build an electric power plant. Such long delays make it impossible to build exactly the right number to meet rapidly changing energy demand, leading to cycles of oversupply and shortage.
So documentation needs to account for those lags.
It needs to meticulously capture a system that is constantly in flux, where these inherent delays can create unforeseen ripple effects and amplify miscalculations. It demands a proactive approach to anticipating and mitigating such systemic issues.
It's like Eliyahu Goldratt's concept of bottlenecks from his foundational business novel, The Goal.
Ah, theory of constraints, yeah.
Identifying these single constraints that limit the entire system's output and then focusing all efforts on alleviating and exploiting them can significantly improve throughput or overall project speed and efficiency.
Find the choke point and fix it.
Applied to construction documentation, this means identifying where information flow gets held up, where processes stall, and focusing efforts there to improve the overall velocity of the project. As Goldratt argued, the goal is to solve problems before they arise, in the design and planning stages, not just reactively.
Which relies heavily on robust, forward-looking documentation and simulation. But even with all that, ensuring the absolute accuracy and reliability of data remains another persistent challenge.
Even with BIM.
Even with BIM's immense promises of interoperability. The BIM Handbook candidly notes that if custom objects, unique components designed for a specific project don't precisely fit into predefined updating structures within the software, the interfaces of these objects with others must be edited manually.
Back to manual workaround.
Exactly. This manual copying, paradoxically, greatly discourages iteration during design because of the immense effort involved and inevitably leads to some level of inconsistency and errors as human fallibility enters the process.
So the ideal BIM model versus reality.
Right. The theoretical ideal of a perfectly integrated, perfectly updated BIM model can often clash with the practicalities and ad hoc nature of a real construction site, where unique solutions are often devised on the fly.
Indeed. There's a perpetual fascinating tension between the idealized reality of a perfectly rendered BIM model and the often unpredictable reality of actual construction. Chris Alexander, cited in Stuart Brand's How Buildings Learn, provocatively suggests that architects can't really visualize how a building will look and feel, nor can anyone else.
Controversial.
And so construction should be a prolonged process of cut and try. This perspective implies a fundamental, almost philosophical gap between meticulously planned, predefined documentation and the often unpredictable, evolutionary, hands-on nature of real-world building.
So build, test, adapt, rather than just follow the plan.
It advocates for an adaptive, iterative approach rather than strict, unyielding adherence to a predefined model, suggesting that documentation needs to capture both the plan and the inevitable deviations and improvisations.
And this inherent tension underscores the crucial ongoing need for constant verification throughout the project lifecycle.
Checking the work against the plan constantly.
Yes. The construction manager, for instance, must rigorously verify contractor work against the meticulously detailed contract specifications as outlined by the CMAA. This also extends to ensuring that all documentation required for crucial sustainability certifications like LEED or Green Globe is absolutely accurate and complete.
Verifying every single requirement has been met before final owner sign-off.
Exactly. The persistent gap between what is painstakingly planned in the digital realm and what is concretely built on site needs to be continually assessed, reconciled, and thoroughly documented, creating a bridge between the ideal and the actual.
Choosing the right tools and having the right expertise for each unique project is also paramount and far from a simple decision, isn't it?
Definitely not one size fits all.
The PMBOK guide states that while project teams often have the best insight into the most suitable tools, these choices must always be tempered by costs and organizational constraints.
Budget always wins, eventually.
It applies to everything from the specific type of software used for modeling to the methods chosen for visual recording, like drone photography or time-lapse cameras, and even how those records are managed and archived. Customization and flexibility are key.
Moreover, modern construction projects are inherently highly collaborative, often involving contributors from contracted entities, channel partners, and other external entities.
A whole ecosystem of players.
Right. This diverse collection of contributors, each with their own specialized knowledge and operational procedures, necessitates carefully tailoring approaches to create one project team from what could otherwise be a fragmented collection of different specialists.
And that means you need diverse expertise for the documentation, too.
Absolutely essential. A wide range of expertise is needed to effectively create, interpret, and leverage the various forms of documentation, from the ancient texts we discussed to the most advanced digital models, ensuring a shared understanding across the entire project ecosystem.
Looking further into the future, the evolving digital landscape promises even more profound transformations in how we document and interact with the built world.
Beyond BIM.
Potentially. The City of Tomorrow discusses how ubiquitous, broadband fiber optic and wireless telecommunications grids supporting an explosion of mobile devices are leading to a profusion of urban big data.
Data everywhere.
This points to a future where buildings themselves and every phase of their construction are constantly generating streams of data, offering new, continuous, dynamic forms of documentation that go far beyond static images or models.
Buildings that self-document, that's wild.
It is.
This leads to the truly exciting and perhaps slightly unnerving concept of spatial cybernetics.
Spatial cybernetics, explain that.
The idea is that architecture moves beyond being just a static container and becomes an active interface between humans, the environment, infrastructure, and an ever-growing network of intelligent devices.
So the building becomes part of the network.
Exactly. This enables spatial cybernetics, a dynamic living system of learning and coexisting. Buildings could transform into intelligent agents with the capacity to learn from and adapt to their occupants, continuously collecting data on their performance, usage patterns, environmental conditions.
Moving beyond static historical records to a living, evolving digital twin of our built world.
Where the very structure is constantly documenting, analyzing, and even redefining its own reality, blurring the lines between the physical and the digital in ways we're only beginning to imagine.
Wow, what an incredible journey we've taken today. We've traveled from the intricate foundational descriptions of ancient architects like Vitruvius and Palladio,
through the practical sketchbooks of medieval craftsmen like Vidar de Honnecourt,
all the way through to the systematic progress photos of modern construction management, and finally into the powerful virtual realities of building information models and 4D simulations.
It's a huge sweep of history and technology.
We've traced how humanity has continuously strived to capture the monumental, ever-changing process of building, not just for the sake of creating a static record, but for crucial project oversight, legal protection, incredibly effective communication, and the indispensable transfer of invaluable knowledge across generations.
Documentation, in all its varied forms, is truly the silent, ongoing narrative of every structure that defines our world.
It really is.
It's an evolving story of how we capture, understand, and increasingly even predict the creation of our physical environment. From the practical necessity of those treasure maps for buried foundations, as Stuart Brand so wisely suggested,
Making sure future generations know what lies beneath.
to the complex digital models that foresee clashes and optimize construction schedules, documentation has become an indispensable and deeply integrated part of the built environment's entire life cycle. It's the memory of architecture constantly being written.
So, as you, our listeners, look at the buildings around you, you've now seen how every beam, every wall, every design choice contributes to a grand unfolding story, carefully documented in myriad forms.
There's more to it than meets the eye.
Definitely. But here's a final thought to leave you with. As we continue to build more and more of our world digitally, with virtual models and simulations becoming ever more sophisticated, even approaching indistinguishability from physical reality, how might this profound shift change our very perception of what a finished building truly is?
Where does the real building reside?
Will the dynamic, ever-evolving digital blueprint become, in some profound sense, more real, more lasting, and more influential than the physical structure it represents, shaping its legacy and its future even before the first brick is laid?